So let's start the next portion of this problem. Now in the previous video we solved this basic problem of section of solid, and it is a problem about a square pyramid, right? So the problem statement was it is resting on its base on HP, and so we can imagine it like this. This is a pyramid which is resting on its base on HP, right? And then it is being cut by a cutting plane which is perpendicular to VP and having inclination of 45 degree with HP. So if you look at it from front, it looks like this, and now it is being cut by a cutting plane like this. Okay, so after section the pyramid looks like this from front. And how it looks like from top, so it looks like this from top. So this is what we obtained in the previous video, and this is nothing but the section, right? Now let's add one condition to this problem statement. Initially it was draw projections of the pyramid. Now I am adding one more condition: obtain true section. Right? Now let's first understand what is true section. So the thing is, when we are looking at this cut pyramid from top, you are able to see this particular section. Alright. So, but the thing is, when you look at it from top, you are not able to see the actual size of the section. Right? Now what is the reason? So you can understand it from here, that if you are looking at it from top, the size which you are observing, that is perpendicular measurement to your eyesight. That means it is this measurement which you are able to see. Okay, this length. This is what you are able to see from top, but actual length is this one, right? So it is obvious that this length value is more than this length value. Okay, that means whatever you are able to see from top, this section, that is not a true section, that is a section with reduced size. Right? So now you can understand the definition of true section. It is the section of actual size. Okay, so if you can see the actual section size over here, that would be the true section. And now we want to obtain it. Very simple logic behind this is that when you look at the section from perpendicular direction, you will be able to see the true section, isn't it? So here if I put the model in front of you again, when the pyramid is resting on HP, you will not see the true section. But if I make this section perpendicular to your eyesight like this, then you will be able to see the true size. Okay, I am one more time repeating. When it is resting on HP on its base, you are not able to see the true section. But when I tilt it in such a way that this particular section, cut section, remains perpendicular to your eyesight, you are able to see the true size, that is true section. Alright, so that is what we will do to obtain the true section. So basically we will try to draw the section by making some arrangement so that we can see it from the perpendicular direction. Okay, now so let's start how to obtain the true section. Okay, now first of all we need to understand that when we look at it from top, right, this particular length is reducing. That is what we understood. But the thing is, this particular length is not getting reduced that will be visible as it is. I am talking about 1, 4 and 2, 3. Right? So when we look at it from top, okay, when it is resting on HP, you will be able to see true length of this and true length of this, that is not getting reduced. Right? Why? Because these two lines, or these two edges rather, are horizontal in nature. If you understand, see, if you look at the pen, I have put the pen along this edge. That pen remains horizontal. That means it is parallel to HP. It remains parallel to HP. That is why when you look at it from top, you are able to see the true length of this edge and this edge. Okay. So now we have one clue here, that it is not required to change the length of 1, 4 and 2, 3. It will be observable as true length. That is why when we draw the true section, it is not required to change the length of 1, 4 and 2, 3. Only thing is, it is required to extend this length. Okay. Now, if we observe this section from perpendicular direction, when we observe it from perpendicular direction, as this is getting increased, right? So here, while drawing, it is not possible that we will tilt this and then we will see. So rather than that, what we'll do is, we will just draw a parallel line to this cutting plane line outside this drawing. So I will draw a parallel line to this. Right? I have drawn a parallel line, and then I will take projections from this point 1 prime 4 prime 2 prime 3 prime, and that is by drawing a perpendicular line to this cutting plane line. So I will draw a perpendicular line to this cutting plane line from 1 prime and 4 prime, and one more perpendicular line from 2 prime 3 prime. Okay, so this line is perpendicular to this cutting plane line. Now we can see that we have now obtained, if I look at this length, this particular length, so that is what? That is the true length between these 2 points. Okay, so that is what we wanted. We wanted to draw true length of this. So now if we draw it like this, first we'll draw parallel line to this, and then we'll take projections from 1 prime 4 prime 2 prime 3 prime. We got that required length here now. So true length we have. Now the only thing is, we have to just put these 2 points 1 prime 4 prime on this projection line and 2 prime 3 prime on this projection line in such a way that this arrangement is reproduced over here. Okay, so that means we want to put this 1 and 4 with the same length over here, and 2 and 3 with the same length over here. Also, we want that the distance between 3 and 4 should be as it is, and 2 and 1 should be as it is, right? So for that, what we will do is, we will take a common reference, and that common reference would be our XY line here, right? So now I am going to first extend this projection beyond, and this projection I will extend beyond, and now I will take a rounder, and then I will measure the distance from XY 2.4, right? So I am measuring this distance XY 2.4, and now here I have a new common reference, and that is this line. So I will put this distance XY 24 on this. Okay, that means I will take center at this point, and then I will cut arc on this. So I will get 0.4 here. Okay, then I will measure xy to 1. Then I will take center at this point and I will cut arc on this, so I will get 0.1. Then I will take xy to 3, this point as center, and I will cut an arc and I will get 0.3. Then I will take xy to 2 and then I will take this point as center and cut an arc over here and I will get 0.2. So now I have to just connect these points and whatever section I am getting over here, that is a true section now. So I can write here that this is true section. Alright. So this is how we can obtain the true section. Okay. Now let's go for next problem. And so let's start with next problem, which is a problem of a right circular cone. So let's first read the problem statement. It says a right circular cone, diameter of base 60 mm and height of 70 mm rests on its base on HP. A section plane perpendicular to HP and inclined at 45 degree to VP cuts the cone and is 10 mm in front of the axis. That means the section plane is inclined to VP and the section plane is 10 mm in front of the axis, right? So now if the section plane is perpendicular to HP and inclined to VP, that will be visible as a line in top view, not in front view like the previous problem, right? So we have to introduce the cutting plane in top view in this problem. Draw its top view, sectional front view and true shape of the section. This is what the problem is. So we will start by drawing the front view and top view of the cone with continuous thin lines initially with the given dimensions. So we'll draw it like this. Now let's introduce the cutting plane. So cutting plane we have to introduce as it is 10 mm in front of the axis and perpendicular to HP and inclined at 45 degree to VP. As I told you that it will be visible as a line in top view because the cutting plane is like this. Okay, it is inclined to VP and perpendicular to HP, right? So now, but where to draw it? So obviously we have to draw a line of 45 degree to XY because the angle with VP is 45. And the where should be the location of it? So here the axis is represented by this point because the axis is perpendicular to HP, so it is visible as a single point in top view and the plane is 10 mm in front of the axis. So we will measure 10 mm from this point and we will mark a point here and then we will draw a line of 45 degree passing through this point and that will be the cutting plane. So basically we are drawing a line of 45 degree here, that is a chain line with thick ends which represents the cutting plane. Okay, so now the cutting plane is obtained. What the problem statement is saying, draw its top view, sectional front view and true shape. So now we have the top view already because if this is the cutting plane, we have to remove this particular portion after cutting the cone. Because if we remove this portion, then in the front view we will not be able to see the section. So we have to remove this portion. That means we are keeping this portion of the cone and now we can make it with continuous thick line, this portion. So we are keeping this. Remember, we do not need to make these lines with continuous thick line, because these are generators, imaginary lines. They are not the actual edges, so they will remain as it is with continuous thin line. Now we need to obtain sectional front view, and for that we need to transfer the points at which the cone is being cut by cutting plane to the front view. So we can see that this cutting plane is intersecting with this circle at this point. So the meaning is, if we cut it like this from here, the base of the cone will be cut at this point. So now we will take projection of this point to the base in front view. Okay, so this is the point, right? Okay, before that let's give some notations also. So let's say this is point A. Then next is, okay, so if this is A, then this would be A prime. Okay, next, this particular cutting plane is cutting this generator, that is O3, at this point. Alright, now when we'll come across this type of point, we cannot take projection directly. See, if I take projection of this point over here, I know that I have to put this point on O3. That means in front view I have to put it on O prime 3 prime. But where to put it? Because if I take projection from this, it will be like this. So where to stop? That we don't know. So for that, always when you come across this type of point, you need to first transfer it to the generator, for which we are able to see the true length. So here you can see that this generator O5, that is horizontal, that means it is parallel to VP. If it is parallel to VP, in front view we will see the true length of that. That means this O prime 5 prime is the true length of this generator. So we need to transfer this point to this generator. So we will take the rounder, point O as center. Let's say this is point B. So we will take point O as center, O to B distance, and then we will transfer by making an arc to the true length generator, that is O5 in this case. Right? Now we will take projection of this point. As this point is on O5, we will take projection of this point on O prime 5 prime. So we will transfer it to O prime 5 prime. Alright? Okay. Now originally that point is on O2 3. So now we will take a horizontal projection and we will put it on O prime 3 prime. And that would be the required point. So I will say now this is B prime. Okay, next, now we have to see next point. So next, this cutting plane is cutting this generator O4 at this point, and let's call this point as point C. So now we have to take projection of this point, and we have to put it on O prime 4 prime. As this is on O4, we have to put it on O prime 4 prime. So we'll take projection of this and put it on O prime 4 prime, and that would give us point C prime. Okay. Next, this cutting plane is cutting the generator O5 at this point. Right, so we'll take projection of this point. Let's say this point is slightly on this side. So we'll take projection of this point on O prime 5 prime, and we'll get this point. So that is point D. So this would be point D prime. Okay, next, this cutting plane is cutting the base again at this point, and we'll take this projection of this point on the base in front view. Let's say that is point E. So this point would be E prime. Okay. So let's check one more time. Is there any point remaining? Basically, we have to just find intersection of the cutting plane with the generators and the base. So we have intersection of this cutting plane at the base, intersection with this generator, next we have intersection with this generator, next we have intersection with this generator, next we have intersection with the base. So no points are left now, all the points are obtained. Now whatever points we have obtained in the front view, we have to connect all those points by a freehand curve. So I will start with A prime, then B prime, C prime, D prime, and then E prime. Alright, and then I know that if the base points will be aligned, right? So this base will be visible as a straight line only. So I need to connect them with a straight line here. So this is the required section. Okay, so that is front view of the section. Now we are removing this portion, so that is now removed in the front view, but we have kept the remaining portion of the cone, so that should be visible as by continuous thick line in the front view as well. So we can say that 1O, that is 1 prime O prime, is still there, it is not removed, right? So that should be represented by continuous thick line. Okay, similarly O to D, that means O prime to D prime, is still there, so we need to show it by continuous thick line. Similarly D to E, that is what we are going to keep. D to E is also there, it is not removed. So D prime to E prime should also be represented by continuous thick line. So that now completes the sectional front view. One thing to make clear over here is that we are representing this edge by a cutting plane line, right? It represents that there is a section. Okay, basically this cutting plane line represents this section. Okay, so but we are not representing it by continuous thick line, but it does not mean that it is not there, it is there, right? So we have to make it with continuous thick line in front view. So that is why we are making this section with thick lines. This is how now the sectional front view of the cone is obtained. So basically if we look at this representation, what we are able to see is this portion of the cone. We have cut the cone from here and we are removing this portion and we are keeping this portion, and then we are looking at it from front direction, right? So if we look at this particular type of cone from front, we will be able to see it like this, right? So let me put it side by side. You can see if we look at this from front direction, we'll be able to see this type of view. Okay, and you can see that this is the base line after cutting. So that is this line, and this is the remaining base here. Okay, now what we want to obtain next is true shape of the section. So we'll follow the same method which we have followed earlier. So we'll start by drawing a parallel line to the cutting plane line. Now as it is observable as a line in top view, we have to draw it in the top view. In the previous problem we have drawn it in the front view. So now I will draw a parallel line to this. Here, then I will draw projections from all these points A, B, C, D, E. So that is perpendicular line to cutting plane line from A, then from B, then from C, D and E. Okay, now I need to extend these lines beyond. So this is my common reference for true section, and I will use XY line as a common reference for transferring the points. So let's start with point A. So if you see, the point A is on XY line here, so I will put it over here directly, that is point A. Now I will represent these points by capital letters. So this is point A. Okay, next the line passing through point B, that is this line. So for that I have to measure distance of B prime from XY. Okay, so I will look at this projection line which is coming from B. Okay, and on this projection line I will measure the distance from XY to B prime. Okay, I am repeating, I will look at this projection line which is coming from B, and on this line I will measure the distance from XY to B prime using compass. So basically I am measuring this distance, and that distance I will put over here. So from this point to the distance, so that means I am taking an arc. I am taking this distance in the compass, then I will take this point as center and I will make arc on this line. So that gives me point B. Next I will look at point C. So this is point C, so I will now measure the distance on this projection line. So XY to C prime on this line, so that is this distance, and that distance I have to put on the line coming from C. So I will put it somewhere here, that gives me point C. Similarly, point D, so on this projection line I will measure the distance XY to D prime, and I have to put it over here, so that will give me point D. Next we have point E prime. So E prime is on the base itself, so line coming from E on the base, that means the reference line which we have decided, and that gives me point E. And now I have to connect all these points by a freehand curve, and this would be a straight line, and this I have to connect by a freehand curve, and that gives me the required section, and this is nothing but true section which we can see when we observe it from perpendicular direction. So I have to also show by a leader line here that this is a true section. Okay, sometimes you will see that it is written as TS, true section. Okay, so again I am repeating here. Always I already told you earlier also that I will not repeat it always, that you have to show all the dimensions. And when you show the dimensions, then the problem will be completed. So here basically you need to show the height of the cone and base diameter. So that will complete the problem.